Good morning, everyone. I'm Krishna from rapidBizApps. I'm the CDO, but I'm basically probably an engineer at heart. The title, I put it aside. So we've been working with Couchbase for close to 3 years now in different forms. And we are here to share our experiences and how we've used Couchbase for what we do. I'll start off with a question. There's a few folks here. So what we take for granted, most of our users, it's a luxury. Anybody want to guess what it is? Why? Somebody guessed it, right? Or they saw this. I'm going to come back to that last slide, but wait. Yes, connectivity. And that's because we work with construction, we work with solar, we work with oil and gas, and we work with mining. And most of these places, there's no connectivity. Or if there is, it's really spotty. They either rely on cellular or Wi-Fi. And in most of these cases, what they want, what they currently do is have paper forms and take them, fill them out, get their managers to approve them. So for an oil and gas location, there's pipeline inspections all along. For a solar installation, the solar installations are, especially commercial solar installations, they're mostly remote, where they have no connectivity. Constructions, they're still out there with no connectivity. So there's thousands of these locations where our operators go to, and they're trying to track, collect data from there. Sometimes it's telematic data, sometimes it's just user data on progress of what they have done. They're collecting all of these, and they want it to come back to their servers for their supervisors to review it, and for the company to be able to track where they are with a particular installation, for example. So the biggest challenge for them is always paper is slow, and even if they went digital, there was no way to get it back to a central server for them. So our challenge was to build something that is easy for them to use and facilitates data collection and coming back to a central server for everybody to review in scenarios where there's almost no internet connectivity. We've done a few things with this. We've started about 5 years ago on building a solution for this scenario. We work with a large equipment manufacturing company. We built our own sync engine for Microsoft SQL Server. And believe me, it took over 2 years, and we're still working on it, and it's still not there. There's so many edge cases with all of the scenarios that we missed out, and we keep fixing them. And we are at the point where, let's replace this. Like I said, it's still in production. Then we decided to look at what was out there, because one of the things we said, we're not good at building sync engines. I don't think that's our core competency. Our core competency is building out the experience. And I think one of my friends here said, we don't build the car. We don't build the transmission, we build the car. So let the transmission be built by somebody else. So we took that example and we started looking out. But at the same time, my engineering team came to me and said, you know what? Let's go to NoSQL. I'll solve all your problems. We'll rebuild it. And that's the typical engineer. We can rebuild anything. We know how to do it best. So I said, OK, let's do it. So we spent a year doing MongoDB and our own sync engine again, and another huge exercise. And the biggest challenges we saw with both MongoDB and MySQL Server implementations were a peer-to-peer sync. As many layers of logic as we add, if we had peer-to-peer sync, that was a difficult challenge. So the application for peer-to-peer sync for us was that the data transferred from one device to a second device, and then eventually back to our server. And it could travel through multiple devices, and it could come to the server from multiple devices, but we still need to make sure that it is a unique data set. So that was a big issue for us when we dealt with peer-to-peer data. So we started looking out for what was available out there, and primary requirement being offline support with peer-to-peer help, eventual sync, and all of that. And then CouchDB, we have our own implementation. We've done something based on CouchDB and MongoDB. We've looked at Firebase, and we've looked at CloudEnt as well. And one of our requirements was that we needed to be able to deploy our solution on-prem for most of our customers. We have a cloud-based solution, but we also needed to deploy on-prem because some of these customers were not willing to let their data out sit in the cloud. And eventually, we figured out Couchbase probably fits our needs best, and we started implementing Couchbase. Almost a year and a half into doing the mobile Couchbase for this particular customer, one of the things when we were evaluating your standard cap tiering, and we were looking at getting at achieving all three, and we all know it's not possible. We tried the traditional RDBMS model, and that didn't work for us. And then we went on to do the MongoDB. But with the offline support, we could do very little. And when we went to CouchDB, we got a little more leverage. But eventually, what really took us to where we wanted with both peer-to-peer and peer-to-peer is still a work in progress. But with offline data sync, really was getting Couchbase with consistency and partition tolerance for us. That was our big key for us. So what we did, what our solution did was we took forms that were paper-based and had workflows associated with them, and we digitized them. And what the user experience is, he would get an invite for the app. An operator would get an invite for the app. He would download the app, log in, and he would see what forms are associated with him automatically. He would fill them in wherever he is, offline, online, doesn't matter. He would fill them in. The supervisor would get the information that a particular event happened. He would look at it. He would approve it. And then the eventual analytics dashboards would get updated on what the status of the whole project was. So that's what we implemented. And our primary key for this was the integration with Couchbase Mobile. And the integration, Couchbase Mobile and getting Sync Gateway up and all. Interestingly, during one of these implementations, our users travel so much between offline and online that we ran into an issue, for example, for our iOS implementation with Apple. There's these areas where we have an access point that's broadcasted, and users start shifting in and out of the access point, and at some point, the iOS devices rather try connecting to the access point and keep failing, and eventually iOS actually blacklists these access points, so it stops trying to connect to these access points anymore. And for us, we're still collecting data, and the only way for the data to get back on that access point was the users to manually go back and connect to it. And even in these scenarios, the application was robust enough to have the data for us and then sync back eventually, be it a cellular-based connection or be it with all the bottlenecks and a Wi-Fi connection that we have. So given that, most of our customers want an on-prem install. The smaller ones are OK with the cloud. Most of us want an on-prem install. So what we did for an on-prem install was what Couchbase recommended: get 2 Sync Gateway servers, 3 database nodes, separate for a separate server for querying, a separate server for indexing, and all of those. And we did it all wrong. We tried to go to the recommendation that Couchbase gave us, but we did it all wrong. I think we had to sit with actually Couchbase for 2 days to reconfigure our querying mechanisms to get our performance down from 30 seconds to I think was 300 milliseconds. So our queries running into a gig of data now were really taking time. So we optimized how we are using our indexing servers and how we are querying to get down our performance from about 30 seconds to about 300 milliseconds for the querying. For the cloud, the same configuration. We started off with the same configuration, and we have applied the same optimizations on the cloud as well, and similar results for us. Now, one thing that most people in mobile would be interested in is how much data are we holding on each of our devices, be it the phones or the tablets. We started out with no limits, and it was a huge bandwidth issue for us because all of the data was, whenever we provision a new device, all of the data was being transferred to the mobile. And the mobiles would slow down because they're querying a gig of data, and they're not capable of it. So And we all know how we control what's on the devices. Anybody? How do we control what's on the devices? No? Okay, channels. The rule is you use channels to control what's on the devices. So, and when people said channels, and we looked at Couchbase's documentation on how to use channels, it was typically associated with authorization, with user access on who has access to what data. That's what rollback access control was what was channels being used for. But then, talking to the Couchbase folks, we said, how do we control this? And their answer again was channels. So we went out and said, we need, let's say, the last 2 weeks of data. In some cases, we needed, well, it's not just 2 weeks of data. There are, for example, in scenarios like this, there are regulatory compliance requirements that says, if a safety issue has occurred, we need the last 4 weeks of data, or sometimes even the last year's data. So we needed to know what documents should stay on the device for how much long. It's not just the creating, just setting a 2-week limit. It also what document should sit for how long on the tablet. So we started doing channels based on days. We started doing channels based on shifts. And now we control exactly what data sits on the device. And it gets recycled every day. So the last day's data gets wiped out. In most of our data is the last 2 weeks. But whenever it's reports that are regulatory compliance requirements, we normally move it into a longer duration. So I think right now for some of those regulatory compliance requirements, some of the data we have, inspection reports and stuff are last a year on the device, because if somebody shows up and requests them for the data, we should be able to pull it off of the mobile. So channels was a big change for us because we implemented without vision of how do we control that data. And then we went back, and now our data size on the devices is, I think, a few megs. And really cut down. It's really what's needed on the device. For querying on the device were like 3 to 4 seconds. Each query took 3 to 4 seconds for us. Is now, we don't even see it. It's negligible. So it's not just using Couchbase, it's also knowing how to use it right for us that got the transition and the results that we were looking for. The other thing was coming off from a traditional solution where we have server code and we manage server code and we have validations in server code, the traditional system, to depending and relying on a sync gateway that took all of the data. And all of the business logic was starting to get built up on the mobile side. It was a difficult transition for us because we're missing how do we control the data on the server, especially the validations part. And if you've tried sync gateway long enough, sync gateway, you can put a lot of logic in sync gateway. Now, I'm still worried that we have to figure out how to split up the code base and manage the code base for sync gateway, but all of our validation logic for multiple document types now sits in sync gateway. I'm sure Couchbase will show us an easier path to manage that, but for now, that's where we're managing all of our server-side validation. We also have a cloud-based analytics solution that runs off of the data that is being generated by all of these mobiles. Our general sense has been that at a worst case, data is laid by the end of the shift. So we get most of the data by end of a shift. Usually shifts are 12 hours, 8 hours or 12-hour shifts. Users come back into some kind of a network zone by the end of the shift, and all of our reports are almost accurate by the end of the shift. But during the shift, there's usually delays. So we always say this, we're trying to get to near real-time updates. The bottleneck really being what's available for the network. So when we did the cloud-based solution, there are customers who are very picky that their data cannot be shared across. How we implement the solution itself, they were worried about it. And they didn't want their data shared among multiple customers in the same database. So obviously, we used buckets and different buckets for different customers. But as we start doing different buckets for different customers, scaling becomes an issue because the capacity for each bucket, we have to assign memory for each bucket, and then the memory capacity for each of our servers is only limited. So I think we have about 7 or 8 buckets. That's the best maximum we've used on any given cluster. And then at which point we either build out a different cluster set or see how we can expand the current cluster set to get more buckets. So what's it for customers? We work with almost no network, and whenever there is network, we get what we need. This is not 100% true. Everything syncs automatically. I was just having a chat with Davis today. Sync, as it runs continuous over the day, and it's not, if you don't turn it off, especially when you drift a lot between Wi-Fi, in and out of Wi-Fi, we've seen sometimes the sync cause crashes. It's not common, but we've seen it happen. So we actually manage some of the sync by forcing to turn on and off as we drift in and out of Wi-Fi. And it's not complex logic, but we do need to manage that. We do manage that sync on top of the base sync that's set up. So turning it on off when we are in and out of Wi-Fi, or when we're in Wi-Fi but we're not able to reach servers. There are scenarios when we are in Wi-Fi. The other case that becomes critical is peer-to-peer. Peer-to-peer connections are always spotty. So it feels like the connection's there, but the data exchange doesn't happen. So those cases are what we would be worried about for the sync engine itself. What does it save? We've eliminated paper. So I guess go green. We've completely eliminated paper. So the users used to record on paper, come back, record on an Excel sheet again, and there was no way to track this. Now there's one central repository for everything. Average of 4 hours saved in their current shift of 8 hours. What's for us? I don't maintain the sync logic anymore. I'm out of it. I do what I do best, build a complete solution. The sync, thanks to Couchbase. The whole offline and sync. Maintenance costs. Nothing. I mean, for me, yes, I did need to reinvest some of my time on managing the sync, but other than that, for me, managing the sync, actual sync between mobile and server is not completely out. I'm doing what I do best, that is build the whole application and the user experience. And that's what matters to us most. And the biggest problem I had when I went with MongoDB was convincing my customers, saying, is this the best solution for them? Deploying it and managing it. I don't have that challenge with Couchbase, at least. When I say, on-prem solution, their first question is, it's SQL Server, and I'm like, no, sorry. And then we went back to, showing them Couchbase and showing them what it did. Most people knew Couchbase by then. The IT departments knew what Couchbase is capable of. So giving them Couchbase was a much easier solution for us. The real challenge, though, is convincing them to get to their preferred architecture for Couchbase. The minimum being your 3-node Couchbase cluster and a 2-node sync gateway. I think 5 machines and managing that, IT looks at it as an overhead. Most larger organizations are okay, eventually they'll get convinced, but I think one of the challenges we see is getting IT to get along with that. But overall, the fact that we're using Couchbase, a lot of these IT organizations are at ease. It's an identified, they know what the evil is. The next big step for us is improving our peer-to-peer, setting up mesh networks and be able to transfer data through mesh networks, getting data out to the right people as quickly as possible. I know we work in a lot of offline environments, and given that we work in a lot of offline environments, getting data out to the right people is really important as quickly as possible. In one of our current implementations, I think we've dropped down the time from end of shift to, I think it's less than, most cases it's less than few minutes. There are cases when they work in a no Wi-Fi area for a while, and in those cases it's probably a few hours. So being able to respond to what's happening out there, especially when there's safety issues for these users, being able to respond to what's happening out there is critical, and that's what we're trying to get to is set up mesh networks and be able to transfer data through mesh networks. And the networks could be of multiple types. I mean, we're looking at our solutions based on RF. We're looking at solutions based on setting up Wi-Fi bridges. And there are multiple things we're trying to get this happen. Well, I think I've already said Couchbase helped us do what we do best, that is build the end-to-end solution. We focus a lot on user experience, how to make, what is the minimal that the user can get away when filling a form? Is it just, if it's just one click for him, that's what he should do. And understanding what we hold a lot of user consults for a lot of our users. We really try and understand what their minimum job is and how do we get them to do, not worry about feeding data, but worry about what they really do. So it lets us focus on building that solution and not focus on what the backend should behave like and tweaking that to make the right optimization to make sure all the data is there. For now, we're expanding into multiple mine sites for our customers, and we're also expanding into with multiple solar sites. Solar companies have been using us. We are piloting in oil and gas, and we're also piloting in individual construction sites. Huge benefit for them. One of the things that everybody is surprised of is that we are getting them what they need sooner, and they're able to adapt and change if necessary on what they're doing. Especially with respect to safety issues, this has been a huge help for them, where site inspections, equipment inspections are almost instantly back on the servers. And if there is an issue, a supervisor can go back, a maintenance person can go back and address them as soon as possible. That's it from me, and I think now would be the time for me to go back here and tell you what we really do. That's our skill. We build really good apps for our customers. So we take away the pain from them. And we improve their actual work time or wrench time, however we want to call that, rather than focusing on all the other stuff. Paperwork, everybody hates it. Get it away from them. Let them focus on what they really do. And that's what we do for our customers. I'm open for questions. Yes. Thank you. Thank you. I'm sorry? I can show you the app. Yeah, sure, I can show you the app. A little bit, yes. Yeah. So we would very rarely, and this is a bug already we've registered with Couchbase, very rarely there's a crash that happens. So we manage the sync, we turn it on and off. Yeah. So when we go into Wi-Fi and we realize that there's a Wi-Fi connection, so we have that constant checking, then we turn the sync back on. When we know that we're out of a connectivity region, be it Wi-Fi or cellular, we turn the sync back off, because it's not a common thing, but we don't want our customers to experience crashes at any point of time. They should, even if there is one, we try and recover from it back to the same state. So we've noticed a few, we've reported it. Hopefully they'll resolve it and we don't need to do. But I think even from a general management perspective of how we're managing our connectivity, turning it on and off makes sense for us.
But with the new SDK, it should be fixed.
That's what I'm told.
Okay.
The magic's still waiting.
Oh.
So you mentioned you've got a bit of analytics wrapped around Couchbase on the back end. And it sounded like that's something third party. Is that something that you'd be looking to use some of the new stuff we've been announcing today sometime in the future, or is that something that needs to be separate?
I'm sorry, repeat that again?
Sorry, sure. So you mentioned you've got some kind of back-end analytics wrapped around Couchbase.
Mm-hmm.
Is that the kind of thing that in the future with full text search, with Couchbase analytics, you'd be looking to fold into Couchbase?
I believe so. I mean, we're still looking at what kind of analytics that Couchbase is offering, but I think we can leverage a lot from what they're building into the new version. Our current analytics are primarily driven by the nickel queries. And again, that's where we had performance issues and they helped us tune to get to the results we want. We're also trying to see, as our data set increases now, we're also trying to see if we should go to Hadoop. And Couchbase has built-in connectors for those as well. So that's something we're still looking at.
Awesome, thanks.
Does Couchbase work better with iOS than Android?
Can you repeat that?
Does Couchbase, it works better iOS or?
That's not a fair question. My team will kill me if I even comment on that. I have not seen a difference between iOS and Android in terms of performance or development time. Pretty straightforward stuff. The only thing that was missing, at least in the 1.5 version, was that Windows UWP libraries were not available. I am told that 2.0 will have those as well. We do have Windows applications as well. So iOS, Android, and Windows. Yes, Windows tablets. We did deploy them as well. Anyone else?
What's the highest number of sync nodes you have deployed? What's the highest number of sync nodes you have deployed?
We only have 2 right now.
2?
Well, on an on-prem install 2. For our installations, I think we're up to 3, but we don't see any need for more than 3. And all our servers are 8 gigs at least, if not more. And the load on Sync Gateway is not really that high. I think the load primarily is on the actual database nodes. Sync Gateway is not, it probably can run on much lighter hardware, and Couchbase recommends 8, so we stick with 8.
Okay.
What is this mesh network, peer-to-peer?
Yes, sir. So, good question, and so a lot of scenarios happen where an operator has a tablet or an iPhone where he's updating some of the data, and he probably never comes back to a Wi-Fi zone or some kind of network connectivity zone. But a supervisor usually drives by most of these operators. So what we've built in is that as long as the applications are running, there's a data exchange that happens between the actual operator's tablet and the supervisor's tablet based on peer-to-peer networking. There's multiple solutions to do that. And when the supervisor comes back to a location where there's Wi-Fi, usually they're office locations, all the data, both from the operator and the supervisor, actually syncs back up. The same pattern, supervisor actually carries data down to the operator as well. So peer-to-peer networking and mesh networking is basically if we can establish a mesh of devices where the exchange happens and the data eventually comes back to the server. Okay. Anything else? No. Thank you, guys. Hopefully I helped.